In today's class, we are going to discuss one important topic which is related to sensory equipment, that is electrodermal activity measurement. We have a couple of two other names which is related to this particular technique, is that galvanic skin response, or you can say galvanic skin resistance. So whatever topic, if you getting the same concept is going to be replicated, whether it is electrodermal activity or galvanic skin response or galvanic skin resistance. Everything is we are going to deal with the electrical activity of the skin. Okay, so this is very simple. Here we are going to see the changes of skin conductance property, electrical property of the skin, which is related to the emotional status of particular person. So the when the person is so pathetic, so panic, or the person is so relaxed, or whatever emotional status that person could be, the reciprocal of that status will represent in our skin. Okay, so by measuring the skin activity, electrical activity, we come to know what is the emotional arousal of particular person. Okay, so how we can do this measurement? In the sense, we simply need two electrode. One is active electrode, another one is neutral electrode. We will place this active electrode to the area where we have a more concentration of sweat gland. Preferably it could be like our palm or our fingers. Okay, so after placing that, other neutral electrode we will place at some distance which is to be nearby your active electrode. And then by means of this electrode we will be pausing some current, constant current source. Okay, so by pausing current, by applying some constant small current source, current by means of this DC current source, based on the electrical activity of the skin, that is the resistance property of the skin, you can see some voltage drop across the skin. Okay, that voltage drop will be the output. Here we are going to measure at voltage drop is nothing but is directly proportional to the resistance property of the skin. This is a very simple concept. Easily for remembering, you can have one formula, that is the Ohm's law. V is equal to IR. Here we are having R is the unknown resistance, and I is the constant source, that constant current source we are going to apply, that is a known one. And then resistance is the unknown resistance. So when you are applying the some constant known current to this unknown resistance, you can have some voltage drop, right? That voltage drop, that is directly proportional to the changes resistance. So based on the electrical conductivity property, if the conductance is high, it will resist more, it will conduct more current. If the conductive property is less, for example, the person have dry hand, the conductive property will be less compared to the person have wet hand. So in that case, you have very low, low resistance, so it will conduct more current when compared to the wet dry hand. So directly it will related to directly proportional to what? Voltage, that is the voltage drop across the resistance. This is the very simple concept. Okay, so and you have two stages. One is A1, that is the amplifier stages for BSR, and A2 we have a amplifier stages, second stage for GSR. Let me tell you what is mean by BSR and GSR. The BSR is nothing but basal skin resistance, and GSR is the galvanic skin resistance. So basal skin response or resistance, what it could be in the sense, the BSR is the resistance of the skin at resting state. Okay, without any stimulus or without any like external activity or stimulus. If you are measuring the activity of the skin, is that that is the basal skin resistance. Okay, so the GSR is the galvanic skin resistance, that is the response of stimulus which is given. The measurement of that response, you have some changes in the electrical activity, which is nothing but GSR. Okay, so BSR is the basal skin resistance, that is you are measuring the skin response to the resting state, and GSR is a galvanic skin response, that is you are measuring the skin response after some stimulus. This is the difference between BSR and GSR. That is the reason you are having two different stages. That is, you have a output stage. One is that A1, and second, that is a pre-amplifier stage for BSR, and second stage could be the GSR, that you have pre-amplifier stage, that is A2. Sorry. So then what is the role of having that capacitor is working with resistance. We have a capacitive series connection with resistor, right? What is the role of this particular series network of capacitor and resistor? In the sense, it act here, it will act as a high pass filter, because in BSR you will having some output in small frequency, okay, small changes. That changes you called as tonic phase. Okay, so tonic phase, that is a resting phase, you will have some kind of changes, some measurement of signal. Okay, so followed by you will have some stimulus, right? So you are giving some stimulus. Now we are going to record GSR. So based on that stimulus, anyway you will have some deviation of signal, that is you have high frequency changes, you have sudden fluctuation in the normal BSR signal. That fluctuation here we consider as a high frequency signal, so that you are having that set network capacitor resistor. That capacitor resistor here, it acting as a high pass filter, so it will clearly pass that high pass signal alone to the next stage. So that high pass signal is nothing but it is the signal which you are getting because of the stimulus given at a particular rate. Okay, so what it's doing in the sense is, CR, this network is now filtering out that particular high frequency signal from the BSR. So that high frequency signal, that phase is called the what is that phasic, once again, phasic response. Okay, so the high frequency changes, the fluctuation in the normal skin response, that phase is called phasic changes. That alone it is being filtered by CSR network, and then we are giving into feeding into A2, that is the amplifier case, second stage of amplifier. So that is the output of GSR. I think now you might have understand what I am telling. That is, BSR is a normal signal, okay, at resting state, and followed by, if you are giving any stimulus, where in response to this stimulus you have some changes in BSR. That changes is having like a high frequency fluctuation changes. That high frequency changes will be filtered out by this high pass filter, and then only that phasic part alone is being given feeded into A2. So from this you are like extracting the high frequency from the normal frequency signal. So in this way you will be getting two output, that is A1 and A2. So that's all about electrodermal activity measurement. Thank you.